Hello everyone, welcome back. So in this section, we will talk about logarithm and exponential function, derivative and integral. Definition, the natural logarithm. The natural logarithm of a number x positive is ln x is equal to the integral from 1 to x, 1 divided by t dt. So this is the definition of natural logarithm. And we have some properties of natural logarithm that you have learned in college algebra. This is to remember those, okay? The domain and the range of ln x are what? The domain is from 0, parentheses 0 is not included, to infinity, because ln of 0 is undefined, right? And the range is negative infinity to positive infinity, respectively. And don't forget the product rule. Ln of x times y is ln x plus ln y for x positive and y positive. And ln of x divided by y is ln of x minus ln of y for x positive and y positive. And the power property, ln of x to the power of p is equal to p times ln x for x positive, and p a rational number. And from college, from calculus 1, the derivative of ln of absolute value of ln of x is what? 1 divided by x. Like the antiderivative of 1 divided by x is what? Ln of absolute value of x for x different from 0. And if you are looking for the derivative of ln of ux, which is what? A composition function. Ln composite ux, the derivative is u prime of x divided by ux. So whatever function you have, inner function you have here as inner function, to find its derivative, it will be the derivative of the inner function divided by itself for ux different from 0. And don't forget, the antiderivative or the integral of 1 divided by x dx is always what? Ln of absolute value of x plus c. So let's go and start. So that's, ln is used a lot because, if you check, we do not have a quotient rule when we are talking about the antiderivative, right? So most of the time, you have to check. Like for example, on this, we are asked to evaluate the integral from 0 to 4, x divided by x squared plus 9 dx. So you can see I cannot separate this one, right? So the best way is I'm going to use substitution so I can apply the ln rule, okay? So like I would say, so to integrate this one, I would say let my u be equal to x squared plus 9, right? Then if u is x squared plus 9, this means what? Du will be equal to what? 2x dx, right? So which mean, right? So which mean 1/2, because right here I can see I only have x, but let's move on that. If x is 4, then u will be what? 4 square is 16. 16 plus 9 is 25. And when x is 0, u will be what? 0 square is 0 plus 9 is 9. So if I'm doing my substitution now, look, we do not have 2x here. We have only 1x. So we have x dx. So that's why, it's up to you how you will see it, okay? I can also say if du is equal to 2 times x dx, then that means 1/2 du will be equal to what? X dx, right? So that's when, if I'm using my substitution now, this is what I would say. I would say my integral from 0 to 4 x divided by x squared plus 9 dx is exactly the same thing as 1/2 This 1/2, I will take it out, right? X dx is what? Du now, right? Because I already took this 1/2 because it's a constant. So du over x squared plus 9, which is u. So do you see? We have u prime divided by ux because du stands for u prime of x, right? Or if I want, I can set 1 divided by u times du. So you know in both cases what it's mean. And the limit of integration is what? 9 to 25. Then we will evaluate this one now. So which will be 1/2 ln of 25. Or let me go step by step, sorry. 1/2 ln of absolute value of u from 9 to 25, which would be 1/2 ln of 25 is positive, so I don't need absolute value, minus ln of 9. We can simplify. The rest is to simplify. You remember this property that I gave you, but ln. So ln of x minus ln of y is what? Ln of x divided by y. So that's what I would apply here. So this is same thing as 1/2 ln of 25 divided by 9. And if you want, you can still simplify because 25 divided by 9 is same thing as what? So you see, it's good to play with this one. 5 divided by 3 squared, and the ln property, 2 will come down. So this final answer will be ln of 5 divided by 3. So let's move on. Definition, the number e, which is natural e. The number e is the real number that satisfies the integral 1 to the integral 1 from 1 to e dt over t is equal to 1. So that satisfies this one, okay? And the definition of exponential function for any real number x, y is equal to e to the power of x, where x is equal to ln of y. You know, we discussed this one, you know, the difference, the inverse function of ln is what? Exponential. And the inverse function of exponential is ln. Okay? So these are some properties of e to the power of x that you need to remember. We will use this one more. E to the power of x plus y is equal to e to the power of x times e to the power of y. And e to the power of x minus y is e to the power of x divided by e to the power of y. E to the power of x to the power of p is e to the power of xp, where p is a rational number. And do not forget, ln of e to the power of x is x, and e to the power of ln x also is x for x positive, because those two are e to the power of x and ln x are inverse function of each other. So theorem, the derivative and integral of the exponential function. So this is the general rule, okay? For a real number x, the derivative of the derivative of e to the power of x respect to dx is equal to what? E to the power of ux times u prime of x. So if whatever the power is, you find the derivative, you multiply by itself. And the integral for e to the power of x dx is what? E to the power of x plus c. So we will be using this one when we are looking for the antiderivative as well, okay? So example, evaluate the following function. The integral of e to the power of x divided by 1 plus e to the power of x. Again, if you remember, we said we do not have a quotient rule when we are dealing with um, integral, right? There is no quotient rule. So by saying that, we need to find somehow how to do substitution to find this integral. And we know the derivative of e to the power of x is also e to the power of x, right? So to solve this one again, so I would say because I cannot break this one down, I would say let u be equal to 1 plus e to the power of x. Then that means my du will be what? E to the power of x dx, right? So this is now, you can see my integral of e to the power of x divided by 1 plus e to the power of x dx, which, I can rewrite as the integral of 1 divided by 1 plus e to the power of x, e to the power of x dx, right? Then we'll just substitute them. Because this is indefinite integral. So if I do my substitution, my u will have 1 divided by u du. And what is the antiderivative of 1 divided by u? Ln of absolute value of u plus c, because the integral is indefinite integral. And now we have to substitute our u back. Okay? So this would be u is what? 1 plus e to the power of x. Do I need the absolute value anymore? No, because this is always positive. It does not kill if you put the absolute value, but since it will always be positive, I'm just going to write a parenthesis and that's it. Hope you have no questions so far. So then next we will talk about the summary, derivative, and integral with other bases. Let b be positive and b is different from 1, which is the base. Then the derivative of log with base b, ux is equal to, sorry, there is a typo here. Okay, logarithm with base b of ux is equal to 1 divided by ln of b times u prime of x divided by ux. Let me make this one a little bit bigger. Okay, that's good. Okay. And for ux different from 0, and the derivative of b to the power of ux respect to dx is equal to ln of b, right, times b to the power of ux, and then times u prime of x as well. For b positive and b different from 1, do not forget the integral of b to the power of x dx is equal to 1 divided by ln of b times b to the power of x plus c. So let's go ahead and do this example. We have to find the integral of x times 3 to the power of x squared. So let's go. Don't forget there is no product rule or quotient rule in integration. So you always need to know if you have to do substitution or the future one we will talk about other way to do integration, okay? So this one is the integral of x, let me write, the indefinite integral of x times 3 x squared dx, right? So again, we already know this rule. The integral of b to the power of x is always what? 1 divided by ln of b times b to the power of x plus c. So if I know this, so that means I can use that to find this one. But how? I first need to use my substitution because this is x squared, not x. So I would say let u be equal to x squared. Then du will be what? 2x dx again. But you see, we already have x dx, not 2. So again, this means 1/2 du will be equal to x dx again, right? And then I will do my substitution. So this means to find the integral of x times 3 to the power of x dx, I can say this what? 1/2 the integral of 3 to the power of u du, which would be 1/2, right? My b is 3, 1/2 times 1 over ln of 3, 3 to the times 3 to the power of x plus c, or 3 to the power of u, sorry. Put x there, 3 to the power of u plus c. And then what is our u? X squared. So I will simplify everything. So which means this will be 1 divided by 2 ln of 3 times 3 to the power of x squared plus c. And that's it. So please use this one because again, everything would be like this. Some problem would be a little bit complicated. You need to use your algebra, but it does not mean you cannot solve them. Okay. I will see you in the next section.